to admin of code. 2025, day 9, movie theater. We slide down the fire pole in the corner of the playground and land in the North Pole Base movie theater. The movie theater has a big tile floor with an interesting pattern. Elves here are redecorating the theater by switching out some of the square tiles in the big grid they form. Some of the tiles are red. The elves would like to find the largest rectangles that uses red tiles for two of its opposite corners. They even have a list of where the red tiles are located in the grid. For example, 7-1, 11-1, and so on. And I can see it. The red tiles are hashtags. You can choose any red tiles as the opposite corners of the rectangle. Your goal is to find the largest rectangle possible. Okay, just two tiles as corners. The largest one is this one. Using two red tiles as opposite corners, what is the largest area of any rectangle you can make? Okay. So we go here, delete this. Let's make these red chords. Split. We can just have points. Yeah, too long. No. Windows. There's 500. We can again try all options. Um, Points with distance. No, we don't need distances, we need rectangle area. This is in, that's pretty fine. So make a PD out of. It's actually two chords, right? What do we need in the end? What's the largest area? We just need the area actually. Then we just do area of this. Isn't it just a dot x? A dot y minus b dot y. It's not really distances, but whatever. Too low. Hmm. Let's see if my calcs are right. 36, 50. 5 times 10. 2, 8. Okay, that's weird. Why isn't that there? Hmm. 1, 2, 5, and 11, 8. We have um, a, no, I'm not getting creative right now. Y equals this. Okay, it's just like 9 is the distance. But actually, I can fit one more. So it's like +1. Hmm. Okay, now I'm at 50. If I go all the way back to here, I get this. Still wrong. Hmm. Wonder if you sometimes don't get the right um, distance. 11, 1, and 2, 5. 11, 1, 2, 5. Now I get it. And what if it's That's the same. Missing anything here? Must be some. Oh, maybe it is large numbers again. Just do this maybe. Um, yep, that's a larger number. Okay. The elves just remembered they only switch out tiles that are red or green. So that your triangle can only include red or green tiles. In your list, every red tile is connected to the red tile before and after it by a straight line of green tiles. The list wraps so the first red tile is also connected to the last red tile. Tiles are adjacent in your list. Tiles that are adjacent in your list will always be either on the same row or on the same column. Oh, okay, so that's part of this data. Okay, let's get it like this, okay. All the tiles inside the loop are also green. Everything else is not green or red. So you still have red tiles in opposite corners, but any other tile included must now be red or green. This significantly limits your options. For example, you can make a rectangle out of red and green tiles with an area of 15 between these two. So green tiles are between them. Thin rectangle, okay, the largest rectangle is here. I guess I have to make this area first of red and green tiles. Then I just check the biggest tiles and see if they're in this area. So maybe we can just fill the area. I don't know how big it's gonna be. Can just make a set of points. Does that help? Do we need it even? Yeah, if we had a set of points, we can check the biggest rectangle, check if it's inside, then check the next biggest one and so on. Currently we are in a kind of areas, I guess. That's fine, I think. Oops. Um, yeah. So we can just make I wonder if it's the same. Like this is an area and this is an area. Well, this would be an area. This would be an area. Yeah, I think this is an area. That's 4. But that's 5. But here we go way thinner, so it's not. It'll overlap into the outside. The areas can be bigger than this kind of path. I don't know how to build the path though. This path. Tiles adjacent will always be in the same row or same column. That's the info I can use. That makes things a bit easier, I think. So I can just go through for each tile. Well, let's go actually. Mm, no, I need the last one as well. And the last one, okay, just say if or when I last index. There's something different. But usually I just go I. Then I see if x is p dot x, then this, else we know that y equals y. Then we just need to add back the half or something. At all points between okay, let me go here. Unit points between AB and this goes there. And we do something like from min to max, map the point hit set of points maybe as well. And then here we do the same, but reverse. Here we need to get points between the last index 5 and the first one. And we always add all points. Let's just do it here. See what happens. Okay. I just assume that's my path. Do we have a path? Hmm. All the tiles inside this loop of red and green tiles are also green. I don't really care about inside the path. I care that my thing is not outside the path, right? Both would work though. But I do have a closed path, so I could flood it somehow. I think that might be easier. I think 1 point that's certainly side of the path. try the small one again. I don't like what I'm seeing here. That switches. Oh yeah, I have a bug here. This would be I don't want it. Yeah, it's not perfectly sorted, but should do it. Example 5, 4, 5, 2, 5. And then must be 2, 4 or something. Yeah, 2, 4, 2, 3, 3, 3, 4, 3, 5, 3, 6, 7, 3, 7, 2, 7, 1. Okay. Okay, well, the easiest is we start at 0. Start at 0, 0. Flood to the closed object. And then we know where the outside is outside. Oh, always that inside, I think. We somehow can. It's just hard to know with the big one. We know that this is an edge. Well, let's just test it. Let's just sort plan A, plan B, side and side. Include the closed object. Everything inside is inside. This has less. This has less stuff. Maybe we should try that. We just have to try this. Trial and error. So let's pick a point that we think is maybe inside. Maybe 9, 8, 3, 17, and 9, 3. And then we just say while not done. Um, we just go next. We also have visited maybe. And then we have visited or whatever. Okay, so there we go. Current and visited. Turnip list for each. We go dir start for each. Um, we also need to check the path. Instead of P. Result is multiple list of points. Result dot add next. Return next. Not result. Resets. And then we have something like that. Let's see what happens. Mm, quite a lot. I think we maybe not inside. Hmm. Let's look at this. Or what I picked it based on. Look at these two maybe. Or let's look at smaller numbers. It's a bit too confusing. Okay, these are also big here. What's going on? Mm, okay, let's just look at these two then. So if this is a line, then take something between there. This one. Jumps from inside like this. Maybe this number of points is just gigantic and it will take long either way. Now I'm going above 5,300. 50,000, although it here is also like that. Let's go the other way. Let's try this. Hmm. The other thing I should try is if it even works with normal example. So here I would choose three, 4, 4 or something. See what happens. Okay, this works. This is around 90,000, 40,000. It's 50,000, 2,000. And then it's 2,000, 50,000. And then it's 50,000, 8,000. Mm, um, okay, this is too big of a space to save, I think. So we will do plan B. Um, well, we do plan C actually. Map Go through the biggest areas, check if they are inside. And I have a new idea. I will just walk. Hmm. Is inside if I can't walk outside to the edge. So basically, I'm thinking, let's see again. If I'm here, like anywhere I walk, up, down, left, right, I hit the path. Or here, wherever. Anytime I'm inside, everywhere I walk, I hit the path. Even here, I mean, here it's easy. I can check, is it on the path? Then it's also inside. Here, can't walk outside the area, and it's fine to walk outside. Kind of hard to tell what's outside, but I know that if I walk to 0 here, or larger than the maximum in this axis, then I'm outside. So that's what I'm gonna do. I'm gonna try walk outside. So um, rid of this. We will say we have a point. Try on the thing again. Let's say 4, 4. And then we check is inside point, inside the path. Check checkpoint path list set of points boolean, and then I go for each direction. Mm, um, I can also do minimum. Outside equals, okay, we will do it once, equals minimum of path, this one. I'm not maybe not the minimum, but min off or no, min off. Okay, it's kind of like min of -1. I have to do it mapped though. And there's dot map. Maybe I just don't map it, but I just take it, so otherwise it's hard to. Let's just say list of these guys, which is this one, or map of this one to Okay, so this is going in the positive y direction, which is, doesn't matter if it's up or down, let's just do max of y plus 1. And then we have the negative x, it dot x minus 1, smallest x minus 1. And then it dot y plus 1, no, minus 1. And then we have max of plus 1 outside. Then I just say this is outside. Then I go outside dot for each is above the end. For each direction and outside. Hmm. Oh, it's super confusing to write. Maybe I'll just write it out in the thing. So we have outside, we don't have it. So we want to go in this direction. That's not one of them. And let's just say we have var c equals p. Well, what we do is like while c dot p smaller than outside is this. Outside we go c plus equals in this direction. And if, well, we always have to check if c is in path, then we can done. And we can also not say done, but we can say inside equals true. Bar done equals false. Just say it's false. We can also end here and then it's just false. Let's see if we can write this nicer. Can just make a function here. Get relevant coordinate returns an int, which is this dot, and then we put a direction in here, which is a point. If direction dot x equals 0, then return this dot y, else return this dot x. So we just return the non-zero coordinate. And then we should also return the path. Um, okay, maybe we can have these here. List of this. I'll just make a list. Where's the stuff here? Oh, actually, this is nice. 0, 1, 2. Okay, we have this map. Then we add it here again. Add it here again. Map of point to int. Just return 2 here. We can just return, well, or is this, and then we have outside map blah blah of direction. Then we return a pair chord and outside direction. And then we have some kind of this can be the function actually. Is inside C then we have C. Oh no, first we get the relevant coordinate. Let's just say not done. Then we get c.getRelevant. Okay, now we can do directions for each. Oh, we don't really want to do that, do we? No, we just have one direction. Let's say now we have the first direction. And then we do dir, outsides. And we can walk in this direction. We can get the relevant coordinate. So what's that? We have which so now we can say if relevant first is smaller than relevant dot second. Okay, now we have something. We can just say is outside. Do return chord smaller than. We don't always want smaller than. We have to do it somewhere though. We can do if kind of the same as before because I'm going X. Like 4 different things. Let me go through all these options. It's greater than Y means we go up, so we want to be inside, and then here the same. This X is small, so we go negative. We want the chord to be greater. Oops. And then if it's small, if it's greater, we want to be smaller. Hmm. Error, invalid, I don't know. Okay, now we can check. Um, if we're in the path or we're outside, or if we're inside. Hmm. If we're outside, then we're done. Done equals true. We're just done then. It's just not inside. If it's in the path, so we hit the path, which is like the outside wall, then we're inside. Yeah, so we should always at some point end. And then we do that for all directions. Um, we can do this now. Directions. And then that's what we map. For each one, we map inside. Insides. Inside count. Four. Then we're inside. Need four to be inside. To hit four walls. To be inside. And now we check. Let's just do it. Print line is inside. Okay, true. And then let's check 10 or like 20. Okay, I'm just walking forever. Like, so X is outside. So what are we doing? We go for all directions. X is also to the X direction. So X is greater than 0. I want my coordinate to be smaller than, what's the relevant one again? The maximum. No, if X is greater than 0, I need to, I'm outside of my chord is greater than, right? I think they're all the wrong way around. My chord, what's my chord, right? Yeah, this. If I'm greater than the relevant, yeah, then I'm outside. The other way around is this. Okay. True. Weird. What happens here? Okay. So what are these? We have the maximum to y is 8, the maximum to x is 12, right? So I should go here in the fourth loop. These are all the while loops. Okay, 1, 0. Now I go here and then like done false, inside false is outside. Direction is 1, 0. I'm definitely outside of 12. Let's check here. So I need the x coordinate. Mm. The relevant direction is 12. I need to check is this greater than 12. True. It is true, so I'm outside. Outside, so I'm done. Not in path, am I? Think so. And I'm up inside. Okay. It's not the same as it. Check. Okay, we just have to check there then. False, true, false, false. Um, oh, maybe I need to filter it. Count it. This is it. I need to count it. Okay, now I'm false. That makes more sense. Okay, and if I'm 0, for example, 0, 0, I wonder what happens then actually. False. I'm just outside. Okay, perfect. I think it should work. Then I know areas. Hmm. Maybe I need to make a list of areas. Not just with the values, but also with, let's see how much left. Area is MA, B, size or S. Then I just map areas. And then I add change area. Long. So we have this max of, then I can go through the areas here. S. Now I can take the area and make it a list of points. Points. And then x equals max. And then we just go all those points. We get the area. Then I go for each point. For each point, check, point, path, sides, they always stay the same. And I can map this. Then filter. Inside points. We found it. What's the question? What's the largest area? Yeah, then I can say area dot s return. And now this small one, let's see. 24. 24. Okay. Then we have the big one. Let's see what this one is. It's just false. I wonder if it's enough to check the boundary actually. Here I'm checking all points in the area, but I think I can check the boundary. So I can just say, hmm, meanwhile, and then min y, min x, I, max x. This is way faster. Know what an area looks like. Hmm, still too slow, I think. Now also how much areas there are. 103,000. But which part is slow? This one maybe? No, that was fast. Checking is slow. So it was good to make it paths, make the points less. Also, I could say found outside equals false. For each, I check. There's only a way. Curious why it's not finishing at all now. I think this returns a this for each, right? Mm. So I can't find it. So if I don't add them all, if I add them all, I also don't find it now. Must have added another bug or something. If this is true, we're inside, right? If this is true, we're inside. Ah, false. We assume we're outside. No, I think let's see if it's left time here. So we only have check. What does check actually do? Need to hit 4 walls to be inside. Is inside. Say it is inside. If is inside. And this point is inside, right? That doesn't mean that any other point is inside. Why do we not check is outside? If it is outside, we found outside, true. We still have to go through to confirm that everything's inside. Okay, what's the issue now? Is okay, so now we get the correct result again. Now we can try if this works for the test at least. Yes. Then we go back here and see if it manages to do one. Okay, even two now already. That's quite good. Then we just let it run. Okay, with a bit of hacking, we got further. Basically, it was just slow, and I added a map point to Boolean. If I know that it's outside at one point, I just return from the map. And then even also here, if I know that a point is outside, I can return from map and also can add it to the map here. So if I did this comparison for this is the point, is it outside or not? I can just add it in the map and then I can skip through a lot of the looping and work. Also, I can early exit, so I can, if I can just say I'm not finished, and as soon as I find something, I'm done here, and as soon as I'm not inside, I'm finished. So I just early exit a few loops, and what happens is that then I can check these areas a bit faster. And then I just go through the list of all the large areas and check if their boundaries are inside. So if that assumption holds, we should be good to go. So then this number, after checking each area, if I actually found one that's not outside, I printed an end. And this is the size of the area. So let's hope this one holds. And it doesn't. So then we have to probably do some kind of double checking, right? Well, first of all, we can check again. Does it work? Yeah, it works. Okay, so the only thing I can think of is, damn it, is that our assumption of the boundary I think I know what could happen. Okay, what I'm doing now is I'm walking in each direction infinitely, and if I don't hit my path, then I know that I'm outside, but I don't know if I'm actually really inside. Hmm. And I think what can happen is that I have a kind of lip where we can do my shape can be here. Let's say have something like this. Maybe we can have like a sketch or something. No. Have something like this. Must be something like, okay, let's just go. I think we could have something like this. Um, if I start here in every direction, I'm hitting the barrier. So I can say I'm inside, but I'm actually not. Because I can, when I take a turn, I can walk out. And my area would be this. But that just means that I have to walk further, not just in these directions. Mm-mm. I don't know how many of those there are. Maybe I can just, like, the solution would be to do a breath first, so I should go out. Alright. If I want to do that, let's just try one hack. You know that one's wrong. We actually know that we can actually start smaller than that. This is wrong. Um, so this. Just get the next one. Maybe just try that until we're done. Bit too high. I don't think we can actually realistically do it because we only go through a few thousand or a few hundred, and actually there's 120,000 options or something. And there's probably a few that are like that. Let's see. Mm, okay, we have to do something, I guess. I don't know if my example is right though, because if yeah, it could be an area like this. And then I just hit some kind of lip here. Let's see. Let's just do it. Okay, so instead of, okay, once more we can go here. Limit this. Instead of, okay, what did I have here? Damn it. No, here it was. Have to check is really outside. I mean, is this an area even? No, I can get the points. No, I don't get the points. Actually, yeah. We just do area is really outside. Then we kind of end up with the normal solution anyway. Um, okay, now we just do all points. And this. And then we do all points is this dot all points, this dot to all points. We only have all points in the area. We can add that to visited. Um, okay, I like the sound of this. It's 2 points. Um, As I say, I visited all points in the area already. I don't care about those. Current is all points minus or all points that filter it not in path. Do we have the path still, right? Do we? So, because if we're on the path, we know we're inside. We don't care. So if current is empty, then return true, because we're just all on the path. Else, and while not done, we go oh damn. And while not done, we go next is find next for current visited path. If we hit the boundaries, we can also stop. That's kind of nice. Also a nicer algorithm. Then we're done. How do we know that we're hit the boundaries? I think we need to check here. I think if it's empty, no. I don't know if it can be empty. If next any oh, I know what I can do. I can make this outside a set of points. Um, it's an area with P of min or these ones basically. Bottom left is mm, Okay, like top left actually. Bottom right is p of path dot. Same with max. Plus, then we just say area of bottom left, top left to bottom right to point. Oh yeah, don't care about the area. Now we just have a set of points. This is the outside. 2 points. Here we can put them in anywhere anyway. So then we have the outside boundary. So if anyone is in the outside boundary, we can just say turn true. If we get through this, yeah, so then we just do find next of current set of points, related set of points, path, what is that? A set of points. Turn the set of points for each point. Mm, I really don't want to go there again. And path, if I hit the path, am I allowed to cross the path? I don't think so. I have to say no. Yeah, we just add the next ones and then we just loop through. Yeah, to set. Cur is next. Okay. How about is really inside? Let me do this. See what this does now. There's some fucking that now. Let's check. 2 points. Here the stars are curious. Oh. Oh, I didn't use it. That's odd. So not doing anything here. All the potential area. Let's see if this. Oh, yeah. See if this part works now. Oh, okay, we're done with day 9. That was really hard. So part 1. What's the largest area of any rectangle you can make? So basically just make these rectangles out of this, and It's pretty straightforward. I was checking all of these now. I don't know if I can turn early. Bam, bam, bam. Um, I'm printing something. Let's see. Let's not print them, and let's print max of it dot s, right? This is the largest. This is the largest rectangle. Okay, so now I have a list of rectangles. How do you do it? You get the coordinates, so the red coordinates, map them to points, x and y. Then I map them to areas, which is 2 points, and s is like the area size. I go through all the combinations of 2 different points. This points, right? Yeah, it's a list of points. I map all the ones together, I get an area, and then I can add that area with the calculated area between the points, which is just the distance between x plus 1, the distance between y plus 1, and then multiplying those. Then I have the areas, so I can go into the list of areas and take the largest one. And then we're done with part 1. So then for part 2, we want to first build this path around all the red boxes. So every hashtag is a box. So we can build this path. And that's kind of a really important hint. Because then I can, if I build this path, I can solve the whole problem easier. So basically what I do is I take 2 points. If they have the same, okay, one thing that makes this easier is will always be on the same row or the same column. So I can say either it's this, x is the same from point A to point B, then the y is different, and I just map all the points from the smallest y to the largest y, and always have the same x, and then the y is differing, and I map this to a set of points. And then similarly, if y is the same, that's the axis that's the same, I do the same with x. So x is iterating and y is always the same, and I have this set of points. You have all of the points between 2 points. Then I have to do this. So I can do this. Um, do like this. And then I don't know what's happened here. This makes sense. Okay, so I get points between, which is a set of points. Then I can add this to my path, and then I have this path of points between. So these are the red ones, and then I have these x points. Also my set, and I have these x ones, and so I have this kind of set of all the points that are on the path, and it's like a circle. And the way I have to connect it is usually I take the current one and the next one, or if I have the last index, I take the first red chord, because then I loop the circle, and I know the path is definitely a circle as well. So then I have a path, which is a set of points, which I was printing here. And then I went through all these different plans. and they all kind of failed, except for the last one. Most of them were too slow, and some of them might logically not work either. So the last plan is make a real outside border. So basically I offset the path by 1. I go and make another one that goes here, and it goes down, and then it goes here. And just make a little border outside here. Because if I know which points are directly outside, I can check if I have my box that I wanted to check. Because what I wanted to do is check what is the largest area of any rectangle you can make using only red and green tiles. And what only red and green means is that the border of this box doesn't touch any points outside of the path that I just made. So I made this path, right? So this is the biggest box because it's the biggest one that doesn't touch any outside points. And it even only is the border of this box that I need to check if it touches the outside points. For example, this is the path. Here's a bigger box. And these points here are on the outside of the box. So that's how I can rule out, like even just checking this point. So I can rule out that this box is not valid to be the biggest one. So the only thing I need to do is then I have a path already. I showed how to make a path. I now need to make the outside path. So what I do is I start with the smallest x and smallest y for the x. So for this column, I have 2 red chords, and then I take the smallest one, so I go here. And then I go left up and say here I start making my outside border, and then I just go around. And the way I can know that it's a valid direction to walk in is I have this path next to me. So here I can go here and here, because next to me is a point that has the path, and then I can go here and I can go here because next to me here is a path. And then when I'm here, I can't go into the path, I can only go up. And I can't go outside because this point doesn't touch any of the path. That way I can just walk around the structure. And yeah, that's what I do. So first I get the smallest one, minimum of x, then the minimum y for those. And then I get one further because the smallest one is still on the path, so I get off the path. Then I start with that. I say my outside path is kind of my visited points in the breadth first search. And then I do my usual not done, take a walk. And here for each current point, I check, can I move in all directions, in any direction? So I go all directions, up, down, left, right, make a point by offsetting my current point into that direction. Then I need to check, is this next to or cornering to a wall? So the cornering use case is edge case is another one where here this one is still my outside path, but up, down, left, right, there's no path, but the bottom right has a path. So I need to check all directions, which is all of those, and also the diagonal ones. Well, I don't want to go back where I came from, where I just added the dirt, so I don't want to go into that direction. But if there's any other direction where if I go after going from the current point into the direction, if I go into that direction again, there's a path. This means I am next to a wall. And then if any of those are true, then, or if any of those exist, then I am next to a wall. So then I just have to check the usual. Have I not been visited? So I don't go back. Am I not in the path? Because I don't want to go into the path. But am I next to the path? I mean, this should be next to path. The path. And then I can add it. Then for each step, I just add points. And then I can check. Yeah, I just make this path. And then what comes out is, let me run this. Okay, this is checking a lot of stuff now. Let's stop it again. Okay, I think I'm printing the path. Maybe I can just return here. Then what happens is, this is the outside path. So my path size is the bottom one is 500 something 1072, and then my outside path is 8 steps longer. So my outside path is a bit longer than my path, so that's a good indicator for I'm on the right track. And then what I do is I sort by descending. So I start with the largest one, with the largest sizes, because I'm looking for the one with the largest size that's inside of my area completely. And then I just check each one. Is the area inside? So basically I can take the diff where I take the current area, make this 2 points, which basically means I take the outside. So if this is the box, I only take the outside wall into account. And then I can check my outside path that I just created. If any of those points, the area contains that point. So if the area contains any outside point, that means I'm outside, which is invalid. Is outside. And then if it's not outside, if this area has no outside points that it hits, then I'm done and I can print the area. And this still is really suboptimal and takes like 10 minutes to run, but it gives the right answer. So what I can do is it's kind of like this, right? See how long it would take if I started at 2 million. So that would take a while, I guess. Yeah, it's pretty slow anyway. So I'll just pop in the something even closer to the solution. Just to kind of skip forward. And I should find it soon. And there we are. So then we found one area, the largest one that's not outside of this path. So that's it for day 9. Enjoy the rest of your day.